Something is being influenced only by gravity. So it is, it's not sitting on the floor where you have the force of the floor acting on it. So the only, it is launched or something, or dropped, or so that nothing is touching it, nothing is acting on it, there's no internal motor. Projectile motion is when the object is moving in 2 dimensions, so not just, straight up and down, that would be free fall. And it's influenced only by gravity. And so in real life, you have things like wind resistance, right, air resistance that will slow something down. But for this class, we're going to mostly ignore that, and I'll be very explicit if I want you to consider something like that. But most of the problems will say you can ignore air resistance. And also things that influence this sort of motion are things like the Earth turning, right? So the Earth is carrying us all around in a circle. It's accelerating us. And we'll talk about centripetal acceleration later on in the semester. But so we can ignore the Earth is turning and just kind of simplify the problem for most cases. So an object is subject only to gravity, that's subject only to gravity, is a projectile, regardless of what its initial position is, whether it starts at the ground or if it starts up high and is dropped, right, and its initial velocity. So just like for free fall, we could throw it up, we could throw it down, right? Still, as long as gravity is the only thing acting on it, the acceleration is due to gravity for free fall. In projectile motion, we have similar ideas, right? So when we have projectile motion, the acceleration in the y is going to be due to gravity, and there's going to be no acceleration in the x. And just like you saw in your quiz, and hopefully you got it right, I know a lot of you did. I forgot to pass those back, but I will. These 2 motions are independent, so you can solve for them, just like we've been doing, just kind of 2 steps, just like you did for the homework. So the acceleration due to gravity, again, is constant, and it's equal to g. We talked about that, which g is 9.81 meters per second squared, and it's pointed down. It's pointed towards the ground. So it doesn't matter, how you set your coordinate system. Positive could be up, positive could be down. Gravity is always going to go towards the ground. And so like I mentioned, there's going to be no acceleration in the x because there's no forces acting on it in the x direction, right? Gravity is just acting downward. It's only in, typically the y direction. And that acceleration, if you assume that your y-axis is, positive, is going up, then the acceleration is going to be minus g in the y direction. And so this helps to simplify a lot of your equations. So when things are 0, that's really nice because those terms just fall out. And you get much simpler expressions from those equations that you already know and love, right? The named ones that we've been looking at. And so you don't necessarily have to memorize these. You just plug in 0 and minus g for the variables that you know are variables, and you don't have to memorize any more equations. You just know that when we're talking about something that's in projectile motion, acceleration in the x is 0, acceleration in the y is minus g if your positive is pointing upward. And then that allows you to simplify these equations.
Wait,
So,
when you're talking about what, projectile motion?
yes.
Okay.
Right, so when you have projectile motion, that means something about ax and ay. And so that gives you variables to plug in. Yes?
We get these on the test.
You get an 8.5 by 11 piece of paper, and you can put whatever your little heart desires on it.
Oh, bless your soul.
Yeah,
Double-sided?
you can put it on all 6 sides.
What?
You can use all 6 sides of paper if you want. All right, any other questions on projectile motion? Okay, very related to free fall, but now we have that second dimension, right? But it's actually pretty simple because you have 0 acceleration. So your x equations, get very simple. Like here, your initial and your final velocity is the same because you have no acceleration. So VOTAT becomes really, really simple. Okay, so now here is a picture. Now this is different than the one that we were looking at for free fall, right? So the axes are different. So before we were looking at, something that was, position versus time. Now this is actually position versus position at different, snapshots of time. And so what happens is the trajectory that you'll see when you launch something, at some angle, right? And then as soon as you release it, it only acts according to, you know, how gravity is pulling on it. What it does is it traces out a parabola. And we can do things like thinking about what is the velocity at this point, right? And so, you know, I could give you, you know, the velocity is 5 meters per second at an angle of 60 degrees counterclockwise from the positive x-axis. And then I could ask a question like, what are the x and y components of the velocity, right? Or maybe I'm giving you a problem, kind of like what you saw in the homework. So if I said, instead of giving you, you know, an initial velocity that was straight up, what if I just gave you an initial velocity that was this way and I said it was in free fall? You could break it into components, and then those components you can use to plug into your equations, right? So when I give you a vector of velocity, I'm actually giving you 2 variables. You can break into those components and have 2 variables to work with your equations. And then of course at the top, you know, of that trajectory, just like in free fall, like if we were to, you know, launch something upwards and it's in free fall, the velocity at the top is 0. And that happens at, you know, if you are starting from the ground and ending at the ground, it happens at half of the time it would take to, you know, get all the way there. So that trick that you saw with free fall, where you looked at just half of the trajectory, you can use that to solve problems if you don't have enough variables. You could think about, you know, if you're just going from the, you know, initial to that top part instead of the whole thing, then you could say, oh, my velocity is 0 at the top. So that trick can come in handy too. Yes.
So what's the big T, little t?
What's the big T, little t? So big T is on this picture, and so little t is just a time slice, right? And so big T is the length of time it takes to make the whole, you know, from ground to ground. So this notation is not super important for the big T here. But that little t is snapshots of time. So that big T is just half of the total time it would take. Good question. All right, and then, so again, analogous to what we were thinking about for free fall, right? We could either start from the ground, end of the ground sort of a thing, or you could start from the top and then just, you know, fall. So instead of just doing where we had like the problem with the guy on the diving board that just steps off the end and falls straight down, you could imagine running off the diving board, right? And then you have projectile motion where you're just starting from the top of that parabola and then falling downwards. So you're going to have some displacement in the x, and you're obviously going to have some displacement in the y, where you're accelerating, you know, according to gravity in that y direction. And so when you're thinking about what variables do I have, you know, there are some that will be implied, right, in the problem. So, you know, things like what are my initial velocity in the y? You know, I might say it starts, you know, with like running in the x direction off of a diving board, right, and then falls off the diving board. So I'm implying that the initial velocity in the y is 0 because there's no component in the y that, you know, that component is 0 in the y. And so these sort of implied variables you can plug into your equations, you know, like, you know, what is my acceleration in the y? It's minus g. So you can plug that into your equation as, you know, something that you already know.
Wait, so this is just like an example, but it could also be like x0 equals h and then y0 equals 0. I mean, it technically wouldn't be h because it wouldn't be height, but like you could start farther along on the x-axis. Like, say if you were jumping, well, okay, maybe it wouldn't be human because you can't do that typically. But if you were like starting on the ground and then you were like going up to a height.
Oh, and you could do it if it was little, right? Like you could jump, and we'll do an example problem.
Yeah.
Where we're jumping up onto, I think it's,
Yeah.
or maybe it's jumping down.
Yeah.
I might be wrong. But yes, you could, so where you set the 0 doesn't matter, right?
Mhm.
Because it's delta x,
Mm-hmm.
right? So all that matters is final minus initial,
Okay.
right? A very good question. And we'll go through some examples. So it might sound like super confusing, like me just talking about it, but when you sit down and do it, it makes sense when you get into it. All I'm saying is that with projectile motion, there's some variables you can figure out that I might not say, oh, and the initial velocity in the y direction is 0, right? Or the acceleration in the y is minus g. All right, so here's our first example. and we have a person who is skateboarding with a speed of 1.3 meters per second, and he releases a ball from a height of 1.25 meters. We're going to go through a few questions with this. My first question is, what is the initial velocity of the ball? And I want it as a vector. Took me a while to figure out if that was a sign or like we were just resting. I want to see if I can vote on this one. Is anyone like, I just don't know what's going on? It's okay. It's okay if you're there in that camp. I've seen like half people. Okay. Does anyone feel confident with their answer and want to describe it?
Wait, I see 1 second.
Just one. Okay, one moment. Oh. All right, actually, so if you are very confident in your answer, actually I'm going to ask you to hold back for a minute. Because I think maybe some of the problem is my notation, and it just takes some getting used to. Right?
Yeah, no, I actually don't know.
Right. So if you know the answer, hold back. If you don't know, let's play along a little bit. Tell me what you're thinking. What's in your head right now about things that could help you get to the answer?
Well, I was thinking low tap, but I realized I don't have an acceleration.
Right.
And then I was like, well, okay, ball speed, the velocity of the ball is 1.3 meters per second, because that's how the skateboards move. The
Okay.
ball is like moving just
Good.
And it's starting at a height of 2.5 meters, and that's how far I got.
Okay, good. Very good. Very good. Okay, so you're breaking down the question, which is exactly what I want you to do. And I will give myself a little board space here. So you've already probably started to think about, and did you draw a picture?
No.
Okay, draw a picture if you're even if you're not confused. Get in the practice of drawing yourself a picture and labeling it nicely. So we have a skateboard, beautiful. Here's a little guy, and he's holding a basketball, right? And the skateboard is moving with some initial velocity, or some speed, right? 1.3, so. All right, so you were saying that the skateboard is moving with an initial velocity of 1.3, and the basketball is moving with it, right? So the speed of the basketball, so the magnitude of the vector of the velocity, right, is 1.3, right? So you know that the magnitude has to be 1.3, so that kind of eliminates a couple of answers here, right? It can't be number 1, because the magnitude of that is 0, so the speed is not 0 of the basketball, right? And it can't be number 4, because that, if you square that and then add it together, you know, those components, and then take the square root, it's going to be bigger than 1.3. So it can't be 1 or 4.
Mm-hmm.
So then what I have left, and just to reiterate, this little I hat means in the x direction. The little j hat means in the y direction. So again, these little hats are for a unit vector, right? And so what it means is it has a magnitude of 1 and a direction that's associated with it. And so I and j are very specific unit vectors. It just means I hat is in the x direction. So this is the x component of the vector that I'm describing. J hat means in the y direction. So this is the y component of the vector that I'm describing. So we've eliminated, you know, the magnitude of these vectors, right? Eliminated 1 and 4. So then what's left is the initial velocity of the ball in the x direction, number 2, or is it in the y direction, number 3? Yes.
So like on a test, like if you said like, what is the initial velocity, you mean it like t equals 0, so like, or like t equals whatever, so like right at the moment when it's dropped, so like the y, anything acts on it?
Yes.
Okay.
Yes. So your initial and your final may vary depending on the problem, right? And just like I had mentioned, so sometimes it's easier to break down the problem into 2 legs of the trip, right? So like for things where, there's an up and then it, hits 0 and then comes down, right? Where it hits 0 velocity and comes down. It might make sense that your initial velocity is halfway through that total time, right? So just be conscious of what you are defining as initial and final. If I were to say that a test is initial, I'll try to set up the problem so it's like, there's only one, there's,
Sure.
what I'm talking about as initial is when the problem has started, right? And then the total, when it hits the ground would be the final.
Do you provide like clarification if we ask like that? On the
Yes,
test?
yes.
Okay.
If you ask me, what do you mean by initial, I will,
Okay.
yes, I will help you with that. That makes total sense to me. All right. So, the answer is number 2. Because it's the ball is moving in the x direction, and it has a magnitude of 1.3 meters per second for the speed. All right. So our goal for this problem is to find the velocity, speed, and direction of motion of the ball at t equals 1/2 second. And what I first want to know is, what are the known variables? So figure out what all of the known variables are, and let me know which one you think it is.
It's just like known variables without any calculations?
Without any calculations, so ones that I am given in the problem, either explicitly or implicitly, right? Without having to do any equations. What variables, I recommend just writing them down on your own so you don't get like influenced and confused by the answers. Just write down all the ones you think you know, and then see if it matches up to one of these things. I'm curious what I said the answer is. Oh, I shouldn't erase that, but oh well. All right, so I'll talk this through because I'm gonna forget what I put as the answer anyway. So I would say that, and we already talked about what the velocity, initial velocity vector is, right? So that kind of gives us the 2 components, Vox and Voy. So 0 and 3.
Yes.
Yeah. And then we also know something about the acceleration because it's doing projectile motion. So what is a sub x? What is the x component of the acceleration?
0.
0. There's no acceleration in the x.
What?
And the acceleration in the y is
Negative 9.81.
minus g. So we can say, yeah, negative 9.81. Good. Good. And then we also know the time, because we're going to be looking at this. I'm curious what I said as the answer. I say you know delta y. I don't.
We don't really know our y. do we?
Yeah, we don't know delta y. I don't know what I was thinking.
Yeah,
Of.
we know.
Is it
Alright,
not
so
1.25 meters?
But we don't know it at 0.5 seconds.
Oh, okay.
Well,
So
do you mean delta y by just like total change in y?
So I mean, so in this case, this comes back to what is the initial and what is the final. So I must have had just a brain fart here. So what the final is in this case is 0.5 seconds.
Oh, sure.
And I don't know how far it's gone. I would have to solve for that,
Right.
right? So
So like if you were to have asked for like initial, we would know delta y, but since you asked for the final, we don't.
No, it's at
Right.
that point.
so if I asked when it hit the ground, then you would know delta y. Maybe that's what I was thinking too.
Because that's what I was thinking.
Yeah.
We would know it, but I didn't
Right.
realize you're asking to do the final.
Yeah, yeah. Are there any confusions on this side? So just get rid of that, right? And that should be the answer. Now, it would be different if I said when the ball hits the ground, but then we wouldn't know time, right? Because we don't know when it hits the ground.
Why is your acceleration always 0?
Because gravity only acts in the line.
Oh, okay.
So if you think about the acceleration vector, whenever it's in free fall or projectile motion, it's going to be 0 I hat minus 9.81 meters per second squared j hat, right? As long as you are, positive, okay?
So you probably all revolve around the person just like, or somebody just without the initial force acting on it. You know what I mean? Like.
So there might be an initial force, but during the trajectory, the only force is gravity acting on it.
Okay.
So if it's projectile motion or free fall,
Sure.
this is your acceleration,
Okay.
right? We weren't thinking about this piece in one dimension, right? But now that we're a vector, this is what it looks like. Good question. Okay, so now my question is, what is the velocity at t equals 0.5 seconds? So hopefully you've drawn yourself a picture, you've written out your variables. Next step, write down some equations that you think can help you out. And you can think about these answers as, the thing that comes before the I hat is what is the x component of this vector. The thing that comes before the j hat is what is the y component of this vector. You have a very good chance of being right. I'm going to say yes. Think so? I'm confident about the x.
I haven't finished it, but it just makes sense at this point.
Okay, yeah, good. I'm confident about the x. That one's good, right? But there's 2 options to have it, so I think it's that one. Looks like some consensus.
I'm pretty sure.
Good. Feel good? Feel confident? Excellent. I'll find out in a bit, but I trust you guys.
He lost his head?
He lost his head. I forgot to say, yeah, this gets a little gruesome.
Fall so hard.
Right?
So is that?
This is a life explorer.
What happens?
Yeah, this is just a PSA, wear your helmet.
This is what happens when you don't.
Yeah.
This is what happens.
You're skateboarding under a low doorway and just.
But keeps going with the basketball.
Yeah.
It's just so.
This is why you're not allowed to speak.
Right.
No, outside the basketball became a projectile.
No, it's go a bit.
All right, well, I see some people still writing and punching things out. So keep going if you're still going. But if you feel confident with your answer, what sort of equations were you thinking about? You use VOTAT? Y flavor VOTAT? You could also use the X flavor too, right? So
Why?
it kind of solves itself, right? So I'll write them down just to be explicit. Okay, so this is VOTAT, Y flavor, X flavor. And then you can use these variables that we have to simplify these a lot, right? So a sub x, and I always forget this, right? But a has 2 components, right? All right, so a sub x is 0, so we get something really nice when we plug that in. Right, so
It's just the same.
it should be the same, right? So it doesn't change. No one should be surprised by that, right? Hopefully. So, oh my gosh, it's clear to me now, right? So the velocity x stays constant the whole time because there's no forces acting on it. Now for this one, when we plug it in, we have a 0 for VOY. So this guy is 0. And then we got minus g, and then we just plug in our 0.5 seconds, right? So the y component of the velocity is minus 9.81 per second squared times a half a second.
Negative 4.9.
Which is that one? Very good. Is that okay? I know the notation can be like a little off-putting, but you will learn to love it. It does make things easier, I think, because like you saw for adding vectors, you just add straight down, right? Hopefully you've seen this. It does make your life easier. I think. I really like using this notation. You will learn to like it too. All right, so my next question is, what is the speed and direction of motion of the basketball at half a second? So so I see some people very confident in it. Some people still working, it's okay. How is the speed related to the velocity? It's the magnitude of it, right? It's the size of that vector. So here's the vector, and so when we want to know what the speed is, that's just the magnitude of this, right? And you can find the magnitude if you look at your vector. So we have something that looks like, plus 1.3 minus something around 5, right? So something like this. Oh, aggressive. I'm chopping off heads, I'm breaking chalk. It's a very aggressive lecture today. All right, so here is, kind of what the velocity vector would look like, right? And so the speed is, what is the length of that? So in order to find the length, I could think of, what are the components of this? Those make it a right triangle, right, where the hypotenuse is the vector, and then this is the x component, this is the y component. So you can use the Pythagorean theorem to find the length of this vector. And so all you do is you square the two components, add them together, and take the square root. So a little Pythagorean theorem.
Whoa, if I take the square root of this one and...
So this should give you at least a good you could probably eliminate all the things now, right, like all the options. But if I didn't give you options, and I just asked you on a test, for example, what is the angle of this vector relative to the positive x-axis, then how do you figure out the angle of this vector?
Oh, where's my pencil?
Yes.
What's the inverse tangent?
The inverse tangent. Okay, so I'm just going to draw a little angle here from positive x. And you can take tangent of theta equals opposite over adjacent. And where those are the two components. Yeah.
But I was supposed to do negative 17. 14.
I did negative 17, but I had a question because it came out negative because of 4.9.
Wait, so if I said okay.
So, yes, you have to be careful when you are using your calculator to figure out angles because of how it defines it. So if you think back to your unit circle, and I forget off the top of my head exactly what range it uses, but some of the trig functions only consider this half, and some of the trig functions only consider this half, I think. So you have to be careful because it will give you the right answer plus or minus 90, right? Or you know, or plus or minus 180, depending on how you plug in positive and negative. I'll tell you my approach. You can choose to ignore it. Here's 4.9. I would find this angle here, and then I would know that the answer is 180 minus that. So I keep it really simple. I just always do the same thing because my calculator confuses me what ranges it is. Keep everything positive, and I draw a picture. And then figure out what makes sense for that angle. Yes?
So do you care if we, do you want us to use like clockwise, like directions, like?
So if I ask you what is the angle, you could describe this in a bunch of ways. You could describe it like I have up here where it's clockwise from the positive x. You could say clockwise from the positive y, counterclockwise from the negative y. I don't care how you describe it, but you have to fully describe the angle. You can't just say, you know, 75.2 degrees. That doesn't mean anything, right? You have to tell me from where. Tell me where I'm starting, tell how far I need to turn to get to it. Right? So I should be able to draw it without you giving me more input, right? So your answer should be, where do I start from, and then how far do I turn to get to where the vector is for that angle. But you can start from wherever you want, but you have to be explicit of where you're starting from. And you could turn clockwise, counterclockwise, that'll just be positive or negative, right, if you're thinking about traditional positive, negative signs of an angle. Very good questions. They can get very tricky angles, which is why I just have an approach, and I just, you know, whatever works for you, stick with that approach. All right. This seems really dangerous. We'll start this one, right? Maybe we'll have time. Okay, so we have a mountain climber that encounters a crevice, and on the opposite side is 2.75 meters lower and is separated by a distance of 4.1 meters. To cross, the climber gets a running start and jumps in the horizontal direction. Our goal is to find the minimum speed that he needs to jump across safely. So we're going to break this down again. My question now is, what are the known variables?
It just seems like natural selection.
Seems like natural selection.
I think we need to go to a crevice and work
We need to go to a crevice and risk our lives for physics.
I feel like
I like where your head's
It doesn't
at.
seem that far.
I definitely feel like that would
Yeah, but you're above by 2.7.
Right, but you also want to run starts, what happens if you slip and then
And on ice.
you can't stop, so you fall off.
Yeah, sure. Well, then maybe we'll get lucky and still be able to roll there.
Right.
Like, we have enough velocity and like speed going.
I feel like
That's what
actually
we talked about.
calculated like the velocity that you would be to actually get into the
What is
window.
velocity?
I haven't seen it, but
I
the
think
way
that
it's
sounds like
good.
rock.
Physics,
I
right?
think you should
Yeah,
do it now.
All right, but bring it back, bring it back. Okay, so variables. What variables do I know? Somebody shout out a variable that I know.
AX,
AX. What is AX?
0.
Okay, another one.
AY is negative 9.8.
Okay, good.
Yeah.
Give me another one.
Delta Y is 2.75. Delta X is 4.1.
Delta X, 4.1.
VOY is 0.
We don't know VOX.
VOY, I agree, is 0.
That's what we need to find though, right?
Right, so we're looking for VOX. So I'll write this over here, just as a note, because we'll use it, right? So hopefully I circled something that makes sense.
Nice.
Good, at least this time I did it, right? Good job, Emily.
Yay.
All right.
You don't call yourself Dr. Shinobi?
I
Only when I'm by
definitely-
myself. Good job, Dr. Shirley. All right. But in public, I'm just Emily when I talk to myself. All right, so next question. What is the minimum speed needed to safely cross? We're jumping right into it. I thought I'd break it down more, but no.
Literally.
No, just, yeah, we're just, pardon the pun. Jumping into it.
Marty's so
I'd rather be jumping onto it though.
Okay, we're jumping onto it.
Yeah.
All right, anyway, what is the minimum speed needed to safely cross? We've got our variables. Hopefully you drew a little picture for yourself. And then think about some equations.
Why does that matter?
Okay, so here's some good candidates. If I just want to do this without even thinking too hard, I'll just circle what I have, right? So let's see, we don't have VOX. We have VOY. We have both of the A's. So we got AX and AY. We have delta Y, which is this. And we have delta X. All right, so we want VOX. So wouldn't it be nice if there was an equation that just had VOX left in it, right? So VOX,
We can find time. If
We have to find time.
we could find time. Can we find time?
The
Yes.
second delta y.
We could find time here. And then, if we had time, we could plug it into this one, right? And then you could solve for VOX. While you guys are doing this, I'm just gonna sneak and pass some back. So that's some X. So in the X fiber, all of these get rid of an X, but it's a delta VOX, AX, but the T is universal. So in this AX is how's it going?
Amazing.
Amazing. Did you get an answer that I have up here? Oh, that's good. Sometimes my calculator skills are iffy, so it's always nice when someone's like, at least I got the same thing. And again, if you get your answer and it doesn't match one of my things, that doesn't necessarily mean you're wrong. So we'll always talk through how to get it and double check that we're all on the same page. Yes.
Because it's asking for speed and time, just leave it in
Ooh, very good question. Very good question. So I'm asking for speed. So is it okay just leaving it as the x velocity? What do you guys think?
Well,
Yeah.
the initial y velocity is 0.
Yes.
So
Good. So,
it's only moving in the x direction.
yes, good. So it's,
Never mind.
yes, you got it? Okay, good. So the magnitude of it is going to be the x component, right? So when you square both, add them together and square root? Yep. Very good. Okay, since we only have a little bit of time, I'm going to show the answer that I got. Yes? All right, let's quickly, we have like 2 minutes. Let's do maybe a quick question. So a rock is thrown horizontally on the moon where there's no air. The initial speed of the rock is v naught. Assume the ground is perfectly level and endless. It's a gigantic moon. Which of the following 3 statements is false? During the entire flight, the minimum speed of the rock is v naught. The rock's acceleration is constant during the flight. The time it takes for the rock to hit the ground increases as v naught is increased. None of the above are false. They're all true. So what are you thinking? What are your thoughts? Are there any you can eliminate?
Well, they have a different gravity. So
They have a different gravity. Yes.
That's not fair.
It's not fair. So what does it mean if the moon has a different gravity? What does that mean?
That AY is going to be different.
AY is going to be different. So let's just say, AY is minus G of the moon. All right, so this could be any number. It could be minus 4, right? It could be anything. It's a different number, right? But it's a number, some number. Still constant. All right, and then we also know, right, it's flat, right? So you don't have to worry about an x component of acceleration. All right, and then what do we know about, so a rock is thrown horizontally on the moon. So what do we know about VOX or VOY?
VOX is going to be the same as VX.
Right, so so this is some constant, right? We'll just say it's V naught, right? Okay? Or VOY,
It's going to be,
thrown horizontally.
right.
No y component to that initial velocity, right? Okay, so let's read these. Let's see. During the entire flight, the minimum speed of the rock is v naught.
That's true.
It's true, right? So it starts off and it's going to keep the same x component for the speed, but the y component is going to start increasing, right? So the overall speed is going to increase. That one's true. The second one, the rock's acceleration is constant during flight. True, right? It's different than when it would be on Earth, but acceleration in the x constant and 0. Acceleration in the y constant. So that one's true also. So it's either 3 or 4. So number 3 says the time it takes for the rock to hit the ground increases as v naught increases. You think it's true? Who thinks that's true?
Well, I don't really know. It
Not
doesn't
sure.
increase
Okay, who thinks it's false?
It would have more
I
inertia.
think it's true.
We have a few people thinking it's false.
Also, my other question is,
And we are out of time, so I'll show you the answer. I'll show you the answer. That one is false.
are you also
why?
And I want you to think about it, and we will talk about it at the start of next time we get together. Okay, why is this false? Think about it, and it might help you to think about it in variables.